Guys, Mr. N here. Our next lesson is about two concepts called domain and range. You probably saw this in your classwork. You're a little familiar with it. But I just wanted to recap so that you can be successful with your individual work. We have a coordinate plane. We're going to use this in a second. But we should first review what it means to be a function. So, if y'all remember, it's been a few weeks of talking about functions now, but a function is specified as an input into a rule and if this rule is a function, that means that it's going to give exactly one output. So usually we see this as an x value being put into a function f of x and giving out a y value. So it's pretty straightforward to see how we can go from the rule into a table of x and y values that we can then combine as coordinate points to put on a plane like so. So let's do an example of this just to be 100% on this, and then we can talk about the domain and range. So for this example, we're going to do the function f of x equals x squared minus 4. So we have this rule. We know we can have some inputs, and they'll give us some outputs that we can label as our y coordinates. So let's do a few values. And as we're doing these values, we're going to make a chart right over here. So we have some x values, some y's, and I'm just going to do a few. So let's do -2, -1, 0, 1, and 2. So we're looking at our f of x. We know we're going to have a lot of inputs. We need to use the rule in order to find all of our outputs. Actually, these should be like so. So we got a blue x and a red y. Okay. So let's start off with x equals 2. When x is equal to -2, x equals -2, we're going to replace our function with the -2. So our function evaluated at -2 is equal to -2 squared minus 4. We step through this. -2 times -2 is 4 minus 4. And we find that our output y is equal to 0. So when x equals -2 or our input equals -2, our output y equals 0. Do this again with x equals -1. So again, every time we see an x, or in our rule where we are required to have an input, so this is saying the function evaluated at -1 is equal to -1 squared minus 4. Simplify it out, we get -1 squared is 1, -1 times -1, remember? Minus 4, so this is going to be equal to -3. So we can do this for each one. We'll find that at x equals 0, our function at 0 evaluates to 0 squared minus 4, or a -4. And then we do x equal to 2, no, x equal to 1. And I'll let you check this on your own for the sake of time, but we'll find that our function evaluated at 1 is equal to 3. Negative 3. And then finally at negative 2, x equals negative 2, or x equals positive 2, because we're right down here at x equals positive 2. We are going to have a function output or a y value of 0. So we have our x's, we have our y's. We know we can now put them as coordinate points. So this converts to negative 2, 0. So we go backwards 2 at 0. Here we go. We have negative 1, negative 3. So an x value of negative 1, a y value of negative 3. When x equals 0, y is equal to negative 4. When our input is 1, our output is negative 3. And finally, when our input is 2, our output is 0. So what we get is a nice function that looks like this. You can graph this on Desmos as well to verify it, but what we have here is called a parabola. We're going to get into that in a little bit, but I want you to know how we constructed this through our function. So when we're talking about domain and range, well, the domain is going to be the set of all possible values of all possible inputs. Or in other words, all the x values which give us a y. Okay? So here we found there's a bunch of x values. There's negative 2 to 2. And if you look at Desmos, you can actually see that we can choose any value we want. Our domain extends forever in this direction, in the positive direction in our graph. And it also extends infinitely far to the left. Okay, so it goes between negative infinity and infinity. So for our example, the domain for x for our function is all real numbers. Means all x values can be put into this function and you can get a y out of it. The next term we're getting acquainted with is range. So domain is to the x values or the input, as the range is to the set of all possible outputs. So here we're looking, if the x-axis is the inputs, just making sure I'm making my graph complete. X is all my inputs, our y's are going to be all the outputs. So this is basically saying all of the possible y values. So if we're looking at this parabola right here, we're going to see a lot of different things. One thing to keep in mind is that these arrows right up here means that as our x increases, or both positively or negatively, our y is always going to be a little bit bigger for every single x. So if I plugged in an x equal to 4, substituted x equal 4 into here, I'd get a 12. So notice how that's significantly higher. So all of our y values, all the possible y values extend up to positive infinity. But unlike the x values here, there is a stopping point. Notice how we have a turning point on our parabola right here at x equals negative 4. That means that our y value bottoms out at -4. There's no x values that you could find that gives you a y value less than -4. So in order to write out this range, we're basically saying all values bigger all values bigger than -4. And what that looks like in math notation, we need to remember our inequalities is going to be y is greater than or equal to -4. So remember for this, the inequality opens towards the bigger value. So we know that our y values have to be bigger than this -4. So we'd write it in this way. So just a good review on what a function is, what inputs and outputs are, how to make a chart based off of our rule, and then how to take that chart, turn it into an equation. And finally, what we added today was actually looking at this graph and trying to figure out the domain or the set of all x values, which can give us a y, as well as the range or the set of all possible outputs. In this case, it starts at -4, extends all the way up towards infinity, and this is how we can actually write it.